many innovations in the future, and one of them is Replicator, which is a machine that is capable of creating objects instantly by voice command. Well, now I'll present to you the future, the Replicator. It's our project where it's a 3D printer that will create objects by voice command. And where we got influence from Star Trek. So, computer, can you print a bunny for me? Well, those are the magic words that will trigger our virtual assistant to send a command 3D printer, which is wired to a Raspberry Pi. And our virtual assistant, which we called computer, and we coded its skill in a way that it will send the command to the Raspberry Pi. In addition to that, we have a web application that is available to guide the user, to assist him and guide him in an easy and flexible way to add or view any model. And you will see that we didn't just create a skill or a web application, but rather what we have created is a complex cross-functional backend which is seamless, that links all of our components and results in an actual deliverable. In addition to that, I would like to add that we ensured that we did not use any database systems deliberately, but rather we used so much Microsoft Azure services that you'll see next in our presentation. Now I'll leave you with Mohammed Hamoud, one of the developers in our team, to show you the main features of our project. Thank you.
As for functional requirements, we have two main functional requirements for Alexa skill and for the website. So for Alexa skill, we have 4 different intents. The list model intent, which lists all the available models which the user can print. And if the user wants to add any model, he would say, so it gives the user guidelines for adding the model, which is through the website, as you will see a while from now. Another intent is the add model intent, which will allow the user to know if he can print a certain model. Okay, these are the intents, and regarding the website, the user will have the upload page where he will be able to upload his model through different guidelines. These guidelines will restrict the user to certain format he will follow, like the G code or the G file. Any other format will not be accepted. Also, a small notice will appear on the screen if similar models are already available in the storage.
Moving on to the technology stack, the items we used and the technologies we used are Amazon Echo Dot 3, Raspberry Pi 2B, Dagoma Neva 3D printer, Azure Functions, Azure Storage Blob, Table, and Cube. Now the diagram is not really that complicated. When you use the website to upload your model, the model is stored to Azure Blob Storage, which will generate a unique URL that you can download from the blob. The URL and the evocation name, the name that you specify in the model, will go through the REST API into the Azure table. And then when you use Alexa, you say, for instance, print a cup. Alexa will take cup and compare it with the list of all available models in the tables. And if it finds a match, it will send the corresponding link to the Azure queue. Now the Raspberry Pi will dequeue the message and send it to the printer to print it. Now for the demo, my colleagues will do it.
Hello, I was in charge of developing the Alexa scale for this project. And for the demo, I'll demonstrate a typical conversation between a user and the Echo Dot. Computer, open the Replicator.
Welcome to the Replicator. Do you want me to give you a list of models you can print?
I do.
You can print a Batman keychain, a bottle, a bunny, a Chinese cup, a coffee cup. Do Do you want to hear more?
Yes.
You can print a Darth Vader, a lion ring, a nuclear tower, a replicator keychain, a tower, and these are all the models available. Do you want me to repeat?
No, I don't.
Okay, you can ask me if I can print a specific model. If that is the case, I can connect to your printer and print it if you wish.
Can you print a bunny?
I am able to print a bunny.
Can you print a tower?
I am able to print a tower.
Can you print the Eiffel Tower?
Unfortunately, I do not have this model. However, you can visit replicator.azurewebsites.net and add it.
Goodbye.
Thank you for using the replicator. Goodbye.
So it can print a tower, however it cannot print an Eiffel Tower. So my colleague Ahmed Fatira will now show you through the website how to add the Eiffel Tower model.
Okay, so after the conversation between computer, our virtual assistant, and Muhammad, we will have to go to the website, to the web application, sorry, not Google Chrome, we will use Microsoft Edge, just as a thank you for Microsoft Azure services. Okay, so this is the main page of the Replicator website, which is hosted on Azure websites. If we scroll down, you'll see an about description, a brief description about our project, and then the founders, and then a quick guidelines for the model upload. And then in case you needed any assistance in your conversation and communicating with our virtual assistant, you can go through the hamburger sign on the right side of our web application. So this is in details how to communicate with Alexa, and there's an example at the bottom of the page. Then our main focus now is how to add models. So our purpose is to add the Eiffel Tower model. So let's add the Eiffel Tower. And for example, if I added a file which is not from the type file of G code or G, we'll see now that it will give us a note that we found similar icons in our models, similarities found like tower, and then you'll have two options, either if you would like to proceed, or if you want to check and stick with the model available, which is tower, and go to and see all the models available. Now we want to proceed and add the Eiffel Tower. So as we've seen before, that we have to add a G code file or a G file. We'll add the Eiffel Tower file. And now it's being uploaded on blob storage. Then through our APIs, it will go and take the blob URL and put it in Azure Tables. So the file is successfully uploaded. Now it will direct us to our models page, which we can see that Eiffel Tower is available. Here it is. So now I'll leave Muhammad to continue with our virtual assistant. Thank you.
Okay, now we'll try again to print the Eiffel Tower model through Alexa. Computer, open the replicator.
There is a problem with the requested skills response.
Computer, open the replicator.
Welcome to the replicator. Do you want me to give you a list of models you can print?
No.
Okay, you can ask me if I can print a specific model. If that is the case, I can connect to your printer and print it if you wish.
Can you print the Eiffel Tower?
I am able to print a tower.
Computer, print the Eiffel Tower.
There is a problem with the requested skills response.
Computer, open the replicator.
There is a problem with the requested skills response.
Computer, open the replicator.
Welcome to the replicator. Do you want me to give you a list of models you can print?
No.
Okay, you can ask me if I can print a specific model. If that is the case, I can connect Connect to your printer and print it if you wish.
Print a bunny.
Printing a bunny will start shortly.
So as you can see, the 3D printer will now start recalibrating in order to print the model.
Print.
So we have calculated the calibrating time, and it takes like 3 minutes 30 seconds. Yeah, that's the problem
We
with
can
the
keep
printer.
it. Why did you start the calibration with the presentation?
Because we have to demo it.
Okay, fine.
The main purpose of our demo is just to show you that how we could connect from our virtual assistant to the 3D printer. Now we will leave you with Omar to discuss what is done and not done and undone.
Project status, what is done, what is not done. Let's start with what is done first. First point obviously is the most important point. Users can print models by communicating with Alexa and telling her what to print. The second point, users can also upload the models to the website just like Mohammed Shatila just did. And for another cool feature is the application name. If the user asks for example, a coffee cup, and the website has only the model teacup, Alexa will not be able to print coffee cup, but in this case, Alexa will tell the user that there are similar models in the website, which in this case is teacup, and it will ask her if you want to print it or not. What is not done, this is more than, it's not nice to have feature. In the future, we're thinking of, instead of the user adding new models to the website manually, we want the website itself from the back end to search other websites and find the specific model the user wants and add it automatically to the storage. And now, Mohammed Hamoud is going to do the learned lessons.
So as for lessons learned, the first lesson we learned is software engineering is much more than just coding. I'm pretty sure that most of you now realize that, as software engineering is itself a process that encapsulates different skills you have to attain in order for the software to succeed. Planning is considered by many experts as the most important one. And for second lesson, we learned to keep learning. So this project has really motivated us to push ourselves through limits and research a lot of stuff, because it really contains different components that we have no knowledge about. So we have to research a lot. And for number 3 is teamwork is powerful. Yes, you can't do everything on your own, and you have to work in a team to have this experience of knowing each other and doing everything together. Thank you.
Any questions?
All right. So, question.
Hi, well done, it was very nice. I just have a question about connecting it to the printer. Is it done like automatically from the printers that are around you, or?
Plug and play. We're trying to make it work with almost any printer. But it's plug and play, just plug it in and have a Wi-Fi connection.
That's it. Okay, thank you so much.
My question is, how is everything connected? How did you connect the speaker to the Raspberry Pi, to the printer? How is everything connected?
We put an API.
You have architecture diagram.
Yeah, we've shown that.
Yeah. Use it while you. Yeah. And a pointer. A key pointer. There you go. And a microphone.
First of all, everything is centered on the API. Alexa will send a request to the API, which will add the link of the model to the queue. Then the Raspberry Pi will check the queue every 10 seconds